here, f of 0 is 7. Down here, f of 1 was 7 2/3. F of negative 2 gave you negative 2 times 3 all over 5 minus 2. So it was negative 6/5. In order to combine negative 6/5 and negative 2, we had to get a common denominator, which made that negative 10/5. So that was negative 16/5. F of 4, 3 times 4 is 12/5. Minus, again, 2, so you make it 10/5. So 12/5 minus 10/5 is 2/5. F of negative 2 gave you negative 6 plus 1, which is negative 5. F of 1 says 3 times 1 plus 1, so you get 4. Remember that function notation simply tells me that whatever is in those parentheses goes in for my x. So you got 1/2 times 4 minus 8. So 4 times 1/2 is 2 minus 8 is negative 6. And 0, 1/2 times 0 minus 8 gives negative 8. Anytime you plug 0 in, you're finding that y-intercept for a linear function. Questions at all on any of those? All right. Then moving on. We have some vocabulary. So the vocabulary in this unit is pretty important. We're going to start with just looking at some of those terms. So a linear relation is a relation that when graphed forms a straight line. A linear relation is a relation that when graphed will graph a straight line. The objective or model for chapter 2 in the first half is all linear. Everything we're doing at the beginning of chapter 2 is finding linear relations. A linear equation is an equation that has no operations other than addition, subtraction, and multiplication. We cannot have exponents or dividing by a variable in a linear equation. A linear function is a function whose ordered pairs satisfy a linear equation. The independent variable is our domain. Oftentimes it'll be the x coordinates. The independent variable is our domain. Oftentimes it is the x coordinates. And again, guys, you don't have to copy my definitions word for word. You are taking those key points. So the dependent variable, that's the other variable in our function. It's usually y. And it's when y depends on x. The dependent variable depends on the independent variable. It is often referred to as the range. The independent is the input. The dependent is the output. So again, independent, domain, input, usually x. Dependent, range, output, usually y. So again, to not make you write so much, standard form of a linear equation is the form ax plus by equals c. Ax plus by equals c, where a, b, and c, and this is important, are integers, meaning they cannot be a fraction, where A, B, and C are integers. And to add to that, the A value has to be positive. Anybody still copying definitions? Okay. And then the second part of this section is the x and y intercepts. The x and y intercepts occur when the opposite variable is 0. So the y-intercept occurs on the y-axis, which is when x is 0. The y-intercept occurs on the y-axis when x is 0. The x-intercept occurs when it crosses the x-axis, meaning the y value is 0. So the y-intercept occurs when x is 0. The x-intercept occurs when y is 0. Awesome. I haven't turned on like my personal hotspot. So again, y-intercept occurs when y is 0. X-intercept occurs when x is 0. Okay. State whether each function is a linear function. Explain why or why not. So in example A, you have 8 minus 3/4 x. In example A, 8 minus 3/4 x. That is linear. We have subtraction and multiplication. You're in one variable, so that is linear. Example B, 2 divided by x. This is non-linear because division by a variable. If you divide by a variable, it is non-linear. Example C, 3xy minus 4. This is also non-linear because I have two variables multiplied together. So I can have division by a number, but not by a variable. I can have multiplication, but not of two variables. So again, in the definitions, we talked about standard form. The two key things you need to take from standard form is that ax and by have to be on the left side of the equation. The a value has to be positive, and a, b, and c must be integers, meaning no fractions as the coefficients. So again, you took down that definition on a slide earlier, just reiterating those key points to try and reinforce them. So it's ax plus by equals c. A has to be positive, and they must be integers. I'm going to screen. So in that first example on that page, you have the 3x minus 6y minus 9. So you have 3x minus 6y minus 9 equal to 0. So in order to make that a standard form, we have to add over the 9. That now gives me ax, 3x, minus by, 6y, equals c, positive 9. Okay, example B. I'm going to write it over here. We have 2y equals 4x plus 5. So what happens is you move your 4x over. So you get negative 4x plus 2y equals 5. But that doesn't satisfy the condition that the a value has to be positive. So I multiply everything by negative 1, like you would for elimination. And you get 4x minus 2y equals negative 5. So my a value has to be positive. And then in example C, we notice that this has a fraction and a negative. So I'm going to multiply everything by negative 10. So that will eliminate my fraction as well as the negative on the x value. So I'm going to multiply everything by negative 10. So negative times a negative gives a positive, and negative 3/10 times negative 10 gives a positive 3x equals, and then what we're going to do is you multiply 8 by negative 10, so you get negative 80y, and 15 becomes a positive 150. So I don't have fractions. My a value is positive, but the last thing I need to do is move the y to be on the same side as the ax. So that becomes 3x plus 80y equals 150. So again, standard form says ax plus by equals c. A is positive. B is A, B, and C are non-fractions. Okay. Let's look at the example 3. So it says the equation 10x plus 5y equals 40 models how you can give change if you only have dimes and nickels. So what we want to do is find all the different ways I can give dimes and nickels as change. We need to make sure we describe the domain and range as well as the x and y intercepts. So let's start with our intercepts. So let's start with the x-intercept. So recall the x-intercept happens when y is 0. So in order to find the x-intercept, we're going to put 0 in for y, solve for x. So when y is 0, x is 4. So that's the point over here on my graph, 4, 0. The y-intercept occurs when x is 0. So plugging in x equals 0, I get 5y equals 40, or y equals 8. So that gives the point up there. So typically when creating a linear function, you can create a line between your x and your y-intercept. Now this is not actually going to graph as a fully linear function because we have to think about giving change. When you give change, can you give, sorry, that was a little crooked. Can you give half of a dime or half of a nickel? Can you give half of a dime or half of a nickel? No. So even though this represents a linear function, we can only select answers from those key points. So that means I could give out 1. So again, remember x is dimes. So I could give out 1 dime. If I give out 1 dime, I have to give out 6 nickels. I can give out 0 dimes and 8 nickels. I can give out 2 dimes and 4 nickels, 3 dimes and 2 nickels, or 4 dimes and no nickels. Those are the only 5 possible combinations. Those are those bolded dots. So when we talk about our domain and range, our domain and range can only be those whole numbers. So your domain is 0, 1, 2, 3, and 4. And your range is 0, 2, 4, 6, and 8. Because I can't give 40 cents using 7 nickels. It is impossible with combinations of dimes. So again, describe domain and range, done. Find our x and y intercepts, done. Create our model, done. Okay, so the last thing we're going to look at is graphing functions using our key points. So this unit is standard form. 2.2 is all about standard form and x and y intercepts. So number 1 is not in standard form. The easiest thing to do to graph x and y intercepts is to change it to standard form. So the first thing I would do is move over my x. So that creates 4/3 x plus y equals 2. Then I'd get rid of my fraction by multiplying by 3. And I know some of us might be able to graph from slope-intercept, but on your test or assessment, I'm going to tell you, put it in standard form, show me the x and y intercepts. So I would ask for your x-intercept and your y-intercept. So your x-intercept occurs when y is 0 or at x equals 6/4. And your y-intercept occurs when x is 0 or y equals 2. And again, you could see that up here if you understand slope-intercept form. So we plot our point 0, 2. And you could plot your point 6/4, which is really like 1.5. And we can see that our slope goes down 4 and right 3. So you'll notice that you can draw in your line and it goes through all 3 of those key points. If I ask you to graph using the x and y intercepts, you only have to have 2. Okay, an example 2. Again, you could find your x and y intercepts by just plugging in the zeros. So if I plug in y equals 0 and solve for x, you get 3/4 x equals 0. Well, we know the only way to get a number equal to 0 is to multiply by 0. So that means that the x-intercept occurs at x and y equals 0, which means that this graph goes through the origin, which means that the x and y intercept is 0, 0 for both. And then our slope again is that 3/4. So you're going to go up 3 and right 4. Okay, and the last one. So we can see that in this example, we have our x and y on the same side, which means that this is in standard form. So example 3 is in standard form. So we can easily find our x and y intercepts by plugging the 0 in of the opposite term. So the x-intercept occurs when y is 0. So that's like x plus 0 equals -2. So you get x equals -2. And the y-intercept occurs when x is 0. So we get that it occurs at y equals -2. So again, these are like the coordinate point, -2, 0, and 0, -2. So we graph those. And connect our points. So to get this one in standard form, again, fractions aren't our friends sometimes. You would add over the 1/2 x. And then we could get rid of the fractions by multiplying everything by 2. So you get x plus 2y equals 1. So now when we find our x and y intercept, we get x equals 1. So what that means is we have the point 1, 0. And we get that 2y equals 1, or y equals 1/2. And again, we can see our slope is down 1 over 2. And there's my line. Lots of good information. Again, with our end goal being Can we get it in standard form? Can we identify linear? And do we know what our x and y intercepts are? So your homework is on those following pages. It's page 72, 16 to 38.